If you travel close to the speed of light, then distances shrink from your perspective. The one number I always have in my mind is at the Large Hadron Collider at CERN, the protons go around a ring, which is 27 kilometers in circumference, and they go around at 99.999999% the speed of light. At that speed, distances shrink by a factor of 7,000. And so that ring is something like 4 meters in diameter to the protons. So according to laws of physics, if you can build a spacecraft that goes very close to the speed of light, you can shrink the distance to the Andromeda Galaxy. And so you could traverse across that distance in principle in a minute. However, the downside is that if you came back to the Earth at that speed to tell everybody what you'd found, at least 4 million years would have passed on the Earth. But getting to chat to everybody about what you found is forbidden.
People are afraid of microwaves.
It's not that they're afraid of microwaves, that they're afraid of things they don't understand. Microwaves, this is a World War II attempt to communicate using microwaves. And they found out some guy's chocolate bar melted in the microwave field. And they said, what happened there? And they did some more tests. And of course, the water molecule and other molecules common in food respond to microwaves. It vibrates them ferociously. And so you put food in a microwave cavity, the water content of the food vibrates, friction cooks the food.
So you don't have to worry about it. It's not doing anything to it. It's not sucking any nutrients out or adding any nuclear radiation.
Correct.
Okay.
It has nothing to do with radiation in the normal sense, other than electromagnetic radiation. We tend to use radiation in the context of stuff that would hurt you. So that would be radiation of high enough energy to hurt you, and microwaves are not in that category.
If civilizations are common, or even slightly common, then there should be civilizations ahead of us, because there's been so much time. You imagine the timescales. We've been around as a civilization, let's give it, say, 40,000 years. The galaxy is pretty much as old as the universe. It's 13 billion years worth of time. So the idea that there are no civilizations arose 100 million years ago, 200 million years ago, 1 billion years ago. And imagine what they'd be like if they'd survived. I mean, we've been around, we've had science for, let's say, since Newton or Copernicus, 500 years at most. And look what we've done. We've gone beyond the solar system with Voyager. We've walked on the moon. We're about to go to Mars, I would think. So we're about to begin colonizing our own solar system. We've done that in 500 years. So imagine a million years in the future. It's one of the arguments often used to say there aren't any civilizations out there in the galaxy. It's called the Fermi paradox. Because if you imagine a civilization that's a million years ahead of us, they should have written their presence across the sky by now. You should see them. I mean, you'll see us. If we survive a million years into the future, we will be exploring the galaxy. We will have spacecraft that are going to other stars. We will be doing it. So our signature will become visible, I'm sure, if we last.
You don't know about this technology? Yeah, it's a future of stealth. So you think you're just seeing the grass in the tree, but there's a car sitting right there where the light that's behind it goes around it coherently and continues to come towards you. So the material has to be able to know what is behind it so that you think you're seeing what's behind it and it's not there. You are seeing what's behind it, but the path of that light went around the vessel and continued on its way to you. Yeah, what you have is like a solid block and a person is looking at it and you see their eye out the other side. It's really freaky. Your rainiest places on Earth are at the equator. That's where you get the Amazon rainforest. And your driest places on Earth are at 30 degrees north and 30 degrees south because these cylindrical movements of air have descending air there. So the Mojave Desert, the Sahara Desert, the Gobi Desert, they're all around 30 degrees north latitude. So we live on the surface of the Earth where there are forces operating that are so much bigger than us. We don't even think about it. India would be a desert because it's right in that zone were it not for the seasonal monsoons. It doesn't rain much in India except when it's monsoon season. So the monsoon is sort of the exception to what would otherwise happen there. And that's why everyone loves the monsoon. They hate it, but they love it.
There's a thing called the Fermi paradox.
Yes.
Paradox is, if we haven't seen it, let's assume we haven't seen any evidence of anything. That's a paradox. We now know there's so many planets out there. So let's say trillions of planets in the Milky Way. The Milky Way's been there for over 13 billion years, pretty much the age of the universe. If there's no one else out there, then the question is why? Because there's been so much time and so many places for civilizations to become spacefaring civilizations.
Right.
We're very close to becoming a multiplanetary civilization. And once you have become a multiplanetary and multi-stellar civilization, if you become that, you're immortal, basically, essentially. The question is, the paradox is, why does it appear nobody has done that? So the first thing to say is, I would not be surprised, right? If a UFO landed here now in the parking lot, I'd actually, not only would I not be surprised, I'd be relieved, because it'd be a weight off my shoulders, because I'm worried
that we're the only
that
ones.
we're the only ones.
That's
and
a terrifying scenario.
There are more molecules of water in this bottle than there are bottles of water in all the world's oceans. So in other words, you scoop a cup of water out of there. I don't even care if you filter it. The H2O is still there. That is water that has passed through the kidneys of Abraham Lincoln, Genghis Khan, Joan of Arc.
Plato.
No.
Jesus?
But yes, Jesus would be included in that. Socrates, yes. Why can you skate on ice? Because the edge of the blade is very high pressure on the ice, and it's melting a bead of water. And you're actually gliding on water when you're skating. You're not skating on slippery ice.
Really?
Yes.
I thought you were just cutting the ice with the blade.
Well, so the blade, have you ever seen a sharpened blade? It's not just flat. There's actually a concave cross-section to it. So each edge, the left edge and the right edge, is basically a knife edge. Okay? Not quite as sharp as a knife, but you can feel how it's sharp, so that when you lean on that edge, either your inner edge or outer edge, your entire body weight is being held up on this very narrow surface area of the blade. So the pressure is extreme. It's like, 1,000 pounds per square inch. You don't weigh 1,000 pounds, but you're not skating on a square inch. What makes it so slippery on ice skates is because you're moving on a bead of water that freezes right behind you as you go past it.
Why can't we take the salt out of the water?
You can. It just takes energy. You can do it.
But why isn't that been being done on
You can.
large
You have to
scale?
ask. Who's paying for the energy? Where are you getting the energy from? It's an energy thing.
But I would think that would be very valuable. I mean, think about how many people buy
It's not
bottles of
valuable
water.
enough yet. That's the point.
Well, is it that
It's pure.
or is
It's
it
just money. It's just money. You can ask, what does it cost to ship half pint of water from Fiji? Okay, whatever the hell is the square bottle that you buy in Fiji water? Is it Fiji, right?
Yeah.
Fiji water. What does it cost to bottle that in Fiji, ship it here, relative to desalinating the ocean? It's cheaper to ship a pint to Fiji. There'll be a day when that's not the case, and future wars are going to be fought over who has access to fresh water.